Memorial RV College presents video lectures, an ISR initiative. SSMRV College, one of the premier institutes run by the prestigious RV group of institutions, has come up with a unique initiative to engage students at the time of this unforeseen medical emergency caused by corona outbreak. As a socially responsible institution, we would like to connect academically with students to make good the losses caused. In this connection, Salma, Assistant Professor, Department of Commerce, has posted a video on the subject Methods and Techniques for Business Data Analysis, and the topic is Indices and Logarithms. Please watch video till the end and like, share with your peer groups and subscribe to our YouTube channel. Thank you. So the topic for today is indices and logarithms. In this current video, I will be covering only indices and logarithms will be covered in the next video, part 2. Don't forget to watch that. So now let us look at indices. Introduction. When an integer or variable is multiplied by itself many times, the operation is expressed in short as a to the power m. It represents that variable a is multiplied by itself m times. When a number is expressed in the form of a to the power m, where a is called the base and m is called the index. So index m can also be referred to as exponent or power. So this can be called either index, exponent or power. All are the same. For example, let us look at one example to understand this indices. If a is 5 and m is 3, then one can write it as 5 raised to 3, which is also read as 5 raised to the power 3, or sometimes also called 5 cubed. This implies 5 into 5 into 5, which is 125. Now, why are indices useful? Indices are needed to save space, time, and also makes it easy to remember and work with numbers. See, like 10 to the power 9 is a better way to remember and also write this huge number which has 1 and 9 zeros. It is difficult to read and remember this number and solve any further problems on this. So it is better to express it in a way of 10 to the power 9. This is the utility of indices. Understood what we mean by indices. Now let us move on to the next very important concept, laws of indices. These are the fundamental laws. By fundamental we mean these are basic laws and also very important to solve any complex problems in indices. If you go through these laws thoroughly, only then you will be able to solve the complex problems. Whenever you look at one problem, you have to be sure which law is applicable to that particular problem. Only using particular laws you will be able to solve the problem. So these laws are very important. Kindly go through these. So now let us look at first law, which is multiplication law. This law can be written as a to the power m into a to the power n will be equal to a to the power m plus n. So this will be explained using an example. Here a to the power 3 into a to the power 2 will be equal to a to the power 3 plus 2. Here m is used as 3, n is 2. So as this law suggests, a to the power m plus n, we have taken a to the power 3 plus 2, which will be equal to a to the power 5. So kindly understand this law, which is very simple and important to solve further problems. A to the power 3 into a to the power 2, you have to add both the powers or exponents and then give the final answer as a to the power 5. Here it is explained how this law can be justified. See here, a to the power 3 and a to the power 2, we have expanded this in this form, a into a, that is a is multiplied by itself 3 times and here a is multiplied by itself 2 times. So together a is being multiplied 5 times, which can be expressed as a to the power 5. Okay, points to be noted. Here are a few points which we have to be noting these points because these multiplication laws have certain important points which will be applied. The terms must have the same base, if not the law cannot be applied. Here, as we have seen in this example, both the bases are same, that is a. In this example, you have 3 to the power 2 into 4 to the power 5, where 3 and 4 are two different bases. So that is not going to be equal to 3 to the power 2 plus 5. This law of a to the power m plus n is not applicable. The sign between the terms must be multiplication and not addition. As you can see in the example, we have taken the sign in between as multiplication. When you take it 2 to the power 2 plus 2 to the power 3, this will not be applied as 2 to the power 2 plus 3. The main important point to be considered is the sign should be multiplication only. The power can be same or different. The powers need not be the same. That rule is only for the base. The terms can be 2 or more. The terms can be 2 or more than that. This law will be still applicable. Now let us look at the second law, which is quotient or division law. This law can be written as a to the power m divided by a to the power n will be equal to a to the power m minus n. So here we can see the two exponents are m and n. In the answer, we have taken a to the power m minus n. That means these two exponents have to be deducted. Now let us look at one example. A to the power 7 divided by a to the power 4, which has to be solved using this law. Then it will be applied as a to the power 7 minus 4. As here m is considered as 7, n is taken as 4. So these two have to be deducted just like m minus n. So we get the answer a to the power 3. Now let us have a look at the justification how this a to the power 3 can be right. Let us expand this entire problem. A to the power 7 divided by a to the power 4. Here we have written in the form of a multiplied by itself 7 times, which is nothing but a to the power 7. And in the denominator we have a to the power 4, which means a is multiplied by itself 4 times. Now, as you know that the same things can be cancelled here in the numerator and denominator. 4 a's which are common in both will be cancelled and we remain with a multiplied by itself 3 times, which is nothing but a to the power 3. So this makes it clear how this particular law works when we have this operation of division. Now let us look at few points which have to be noted. It is very similar to the previous law. The terms must have the same base. If not, the law cannot be applied. For example, see in this previous example, we had the bases a and a. Both the terms had same base, so the law was applicable and we have seen that. But here in particular example we have taken here is 6 to the power 2 divided by 3 to the power 3. Here the bases are different. So this particular law is not applicable. The next point is the signs between the terms must be division and not subtraction. Very important point you have to consider when you are solving these problems is the sign. You have to be very sure of which sign is given in between the terms. If it is multiplication, division or any other sign, the rule will be different for each. Let us look at one example. 2 to the power 5 divided by 2 to the power 3. As per this law, because we have division and the two bases are same, this particular law will come as 2 to the power 5 minus 3, which is 2 to the power 2. Now let us look when we have the same number, same base, but the sign here is subtraction. That means it is not division. So this particular law of a to the power m minus n cannot be applied because 2 to the power 5 is given as 32 and 2 to the power 3 when expanded will give you 8. So when you deduct 32 and 8 you get 24, which is not equal to 2 to the power 2. So by this you can understand that this law is only applicable when you have the division operation. The power can be same or different. Here the rule is only between the terms and the sign, but the powers can be same or different. It has no restriction on that. The next rule is the terms can be 2 or more. As you have seen here only 2 terms, it can be more than 2. Still the rule will be applicable. Let us look at the third law, which is power law. This law states that a to the power m whole to the power n can be written as a to the power mn. Here mn means the product of m and n, that is m into n. Now let us look at one example to understand this clearly. A to the power 4 raised to the power 2 will be written as per this law, it can be written as a to the power 4 into 2, that is again the product of these two exponents. That can be finally written as a to the power 8. Now let us see the expansion for these terms. A to the power 4 can be written as a multiplied by itself 4 times whole raised to the power 2. Now this raised to the power 2 means that it has to be doubled. So in the next step we have taken a to the power 4, that is a multiplied by itself 4 times, again a multiplied by itself 4 times. This will become the square. So together it comes to a to the power 8 because a is being multiplied by itself 8 times. So this law is justified seeing this particular example. Let us look at the next law. These are the derived laws, that is law 4, zero power law. It is simply put as anything. Note this, anything to the power of 0 is always 1. That means whenever you have anything like a to the power 0, that will always give you the answer of 1 and nothing else. So it is justified in this following steps. A to the power m divided by a to the power m will give you a to the power m minus m, which can be written as a to the power 0. Again, this can be expanded in the following way. A to the power m divided by a to the power m, which will get cancelled and give you 1. So ultimately you have this a to the power 0 is nothing but 1. Let us look at law 5, negative power law. That means your power here has a negative sign. For any base other than 0, a negative index makes the power function an inverse of 1 with a positive index. That means if a is any non-zero real number and m is any positive integer, then it can be written as a to the power minus m. Whenever you have this negative power, it can be expressed as 1 by a to the power m. So this negative becomes positive only when you transfer this to the denominator. Please note that the minus sign will be removed when you are transposing that term to the denominator. Now these are some basic other laws which have to be gone through to solve your further problems. We have already seen all the laws. Now let us move on to solving some basic problems. All these problems will be solved using the laws which we have already understood. Now see, the main important thing whenever you are going to solve any problem is that you have to know which law is applicable. So going through those laws thoroughly is very important. If you understand the laws, then solving any type of problem in this indices concept will become very easy and simple. You will solve it in very less time and the answer will be definitely correct because you are going through the laws. Now let us look at the first question, a very simple one. Simplify 5 to the power 3 into 5 to the power 2. This is the question. Now as soon as you look at this expression, you need to understand that this is the multiplication operation. So we need to apply multiplication law. So in the solution, as you can see, we have taken this particular law, which is the multiplication law. Here we have seen that a to the power m and a to the power n, that the answer should have the exponents need to be added. So same when you apply to this particular question, 3 and 2 are the two powers or exponents. In this you can see the bases are the same, 5 and 5. So no worries about the base and the exponents. You can directly apply this law, 5 to the power 3 plus 2, which will give you 5 to the power 5 and which can be further expanded to 3125. Now let us look at the second problem. Simplify 8 to the power 3 into 16 to the power 2. First thing to understand is it is the multiplication operation. So you are going to apply multiplication law. But one thing different from this problem and this problem, as you can observe, is the bases are different. So now, as we had already seen in the point to be noted when looking at the law, bases need to be same. So how will you solve this problem in the coming steps? So you are going to take the laws, but before that you have to see this important point, that is you are going to express these two in a common base. So convert both the terms, that are 8 and 16, to a common base 2, and then only you can simplify. So 8 can be expressed as 2 multiplied 3 times, which is 2 to the power 3, and 16 multiplied 4 times, that is 2 to the power 4. So now you can see we have common bases. Now you can easily go ahead with the multiplication law. The first step here to be very careful about is the bases. You have to make a common base and then solve the problem. So as you can see, the same question is taken here, 8 to the power 3 into 16 to the power 2, and it is expressed as you can see here again, 8 is substituted to 2 to the power 3, 16 is substituted to 2 to the power 4. The rest remains the same. You can apply this law of a to the power m whole to the power n, a to the power mn. That is what we have taken the product of these two, and 3 to 3, all these things you can see the calculations here. These laws will be applied, and finally you can apply the multiplication law, adding the powers of these two terms, that is 2 to the power 9 plus 8, which will give you 2 to the power 17. You can leave it as it is here. Moving on to the next problem. Here, evaluate 1.5 to the power 5 divided by 1.5 to the power 3. Now this has a division symbol. That means this is a division or quotient law. Now as per the law, we have the same basis, so no need to worry about the basis. Now you can directly take that m minus n, that is you are going to deduct the two exponents 5 and 3. So you will land up to 1.5 to the power of 2, which can be further written as 2.25. Next problem, simplify 16 to the power 3 by 4. Here you have the exponent in a fraction form. So we are going to express this 16 in the form of 2 to the power 4, as it will be easier for us to further solve this problem using any law. So we are going to take this 2 to the power 4. So here substitution done. 16 is written as 2 to the power 4 whole to the power 3 by 4. So as you can see, a to the power n whole to the power n should be written as a to the power m into n. Take the product of these two exponents. Here 4 and 4 gets cancelled as it is multiplication, and you will land up with 2 to the power 3, which is nothing but 8. Let us look at the next problem. Simplify fourth root of 18 to the power 4. This is another law which we have listed in the other laws. Apply this law. The cubed root of a to the power p can also be written as a to the power p by q. This root here gets to the denominator. So as this problem has fourth root, so you are going to take this as it is 18 to the power of 4 whole to the power of 1 by 4. This 4 here becomes 1 by 4 because this has to be in the denominator by q. That means it is in the denominator, so you have to take 1 by 4. So now as this is multiplication here, you are going to take product of these two. 18 to the power 4 into 1 by 4. So as it is multiplication, you will cancel 4 and 4 and you will remain with 18 to the power of 1, or simply you can tell it as 18. Let us look at the next problem. Evaluate 10 to the power minus 4. This has a special significance here that the power is in negative. We have not seen any problem till now which has a negative sign in the exponent. Now we have also looked at a law which has the negative power. So this law is a to the power minus m can be written as a divided by a to the 1 divided by a to the power m. So this negative becomes positive as it has gone to the denominator. So when applying this law to this problem, 10 to the power minus 4 will become 1 by 10 to the power plus 4. This minus 4 has become plus 4. Note this, the change in the sign. So now 10 to the power 4 can be written as 10,000. So 1 divided by 10,000 will be equal to 0.0001. Now how will you transpose this decimal pointers? You have as it is 10 to the power 4, so you have 4 zeros and you are going to have 4 digits in the after decimal. So that is how you are going to transpose this decimal point. Let us look at another problem. Find the value of 81 to the power of 0.5. So this 0.5 is another new thing which we are seeing in this problem. So in the solution we can see 81. As this is a huge number, first thing what we will do is we will convert 81 to the simple common base, that is base 3. 3 multiplied by itself 4 times will give you 81. So you are going to substitute 3 to the power 4 in the place of 81, and this 0.5 can be written in the form of 1 by 2. 0.5 is nothing but 1 by 2, that is half. So now a to the power m whole power n will be a to the power m into n, product of these two. 4 into 1 by 2. Again here 2 and 4 can be cancelled. So here 4 will become 2 because 2 1 and this will become 2 twice. So that is 3 to the power 2, nothing but 9. I think you are clear with these simple problems. The only thing to consider is that the laws are very important. We have few other complex problems which will be seen in the further slides. Now we have seen here multiplication, division and few simplification problems. We'll have another few problems to understand this in depth, but the only thing you have to consider is that each problem has certain laws to be applied, and if you apply the law correctly, you will derive the correct answer. Now we have few more problems to understand the concept of indices and the laws in depth. Now let us look at this question number 8, which has simplify 256 to the power of 0.16 into 16 to the power 0.18. Now first thing you have to see is it is a multiplication operation. So yes, you can apply the multiplication law, but before that confirm whether the bases are the same. And here in this question the bases are not same as of now. We have it as 256 and 16. So the first step is to convert the two bases 256 and 16 to a common base 2 and then simplify. So 256 can be written as 2 to the power 8 and 16 can be written as 2 to the power 4. So these are converted to a common base. Now when you substitute, you are going to write 2 to the power 8 in the place of 256 and 2 to the power 4 in the place of 16. So when you are solving this step, you can see a to the power m whole power n will be the product of these two, m into n, 8 into 0.16. The same applies here as well. So when you solve this, you get 2 to the power 1.28 into 2 to the power 0.72. Finally, when you get to this step is only when you can apply the multiplication law. That is, you are going to add m plus n. That is, you are adding the two exponents. When you add this, you get 2 to the power 2, which can be written as 2 into 2, 4. The next problem is simplify 32 to the power of 6 into 27 to the power of 2 divided by 64 to the power of 5 into 9 to the power of 3. Again, all the four terms have different bases. So the first step is to convert the bases into a common one. So you have to take this in this form, 32 and 64 as one set and 27 and 9 as another one. So 32 and 64 you have a common base 2, 27 and 9 you have a common base 3. 32 is written as 2 to the power 5, 64 is written as 2 to the power 6. You have common bases now. 27 is written as 3 to the power 3, 9 is written as 3 to the power 3, 3 to the power 2. These two are common bases. Now again, when you see this law, a to the power m whole power n is written as the product of these two, m, n. So that is why we have substituted the following steps using that law. 5 into 6, 3 into 2, all this applies that you are multiplying the two exponents. So 5, 6 and you are going to get this value. After getting this value, you have to write it in this way. That is 2 to the power 30 minus 30. This is because you have these two as same bases. A to the power m divided by a to the power n will give you a to the power m minus n. You are deducting the two exponents. The same applies for this as well. You are deducting the two exponents. So when you deduct the two exponents, you get 2 to the power 0 and 3 to the power 0. Anything raised to the power 0 will be 1. So both the terms have 1 and 1, which is nothing but your final answer will be 1. So this looks like a complex problem, but when you solve it step by step, it becomes very easy. The only thing you have to worry about here is which law has to be applied, and the laws need to be applied according to the steps. First, you have to apply a different law, and only when you reach the final one, you can use these laws. If you try to apply this multiplication or division law in the initial steps, you might go wrong. So first, simplify as much as possible and then move on to the multiplication law. Okay, now let us move on to the next question. Evaluate 0.00032 to the power of 3 by 5. So here you have a long decimal number and a fraction in the exponent. First, you are going to convert 0.00032 into fraction form because that will be simple and easier to solve. So this can be written as 32 by 1 lakh. The trick to write here is you have after the decimal 5 digits. So you should have 5 zeros in your number. That is how you are going to arrive at this 1 lakh. 32 by 1 lakh to the power of 3 by 5. So now again you have to simplify this further. 32 can be written as 2 to the power 5 and this 1 lakh can be written as 10 to the power 5. 10 and then you are going to write the 5 zeros. As you have totally you have 5 zeros, so you are going to write 10 to the power 5 and the whole is raised to the power 3 by 5, which will again come to 2 by 10 whole power 5 because you have common exponents here, so that is taken out of the bracket, and the final one 3 by 5 here. Now when you solve this 2 and 10, you arrive at 1 by 5 when you solve it, and this 5 into 3 by 5 will again be the product of the two exponents, and 5 and 5 will get cancelled and you will arrive at 1 by 5 to the power of 3, a common power till now. When you can move ahead by 1 to the power 3 by 5 to the power 3, as this is common, 1 to the power 3 will be 1. Anything, whenever you have 1 to the power, anything will give you 1 because 1 multiplied by itself as many as times as possible, it still gives you 1. So don't get confused with this. 5 to the power 3 is nothing but 125. So your final answer is 1 by 125. Let us move on to the next question. Simplify 5 to the power 3 square divided by 5 to the power 3 whole power 2. Okay, now when you look at these two terms in one shot, you feel these two terms are the same. But for your information, these two terms are very different from each other and finally gives two different answers. It looks the same because you have 5, 3 and 2. Here you have 5, 3 and 2. But the main difference here is 5 is raised to the power 3. This 3 again has another power 2. So that is 3 square. And here you have 5 to the power 3. This entire term is raised to the power 2 and not only the exponent. But here only this 3 is raised to the power 2 and nothing related to this. So when you are solving 5 raised to the power 3, this raised to the power 2 will give you 5 to the power 9 because this is 3 square. That is 3 into 3, which gives 9. So 5 to the power 9 divided by, as it is, 5 to the power 3 into 2, that is m into n. You are taking the product of the two exponents, which will give you 6. So now these two terms are finally simplified to a form that you have these two terms which you can apply the quotient or division law, which is m minus n. That means you can deduct the two exponents because these have the common base. So 9 minus 6 will give you 5 to the power 3, which is 125. So this is how you solve this problem. The only difference here is this new expression 5 to the power 3, that is 3 square here. Questions are based on the laws of indices involving numbers and are structured where 1, 2 or more laws can be used at a time. So as you have already seen in the problems that there is no one single law for one single problem. Multiple laws can be applied to one problem to come to the final conclusion. The only aim is to simplify the problem as much as possible with the help of laws. So apply as many laws as possible, but only the relevant ones. Now let us look at few more problems which are a little different from what we have seen previously. Now, as you can see in this question, find the value of 9 to the power 2 into 18 to the power 4 divided by 3 to the power 16. This is similar to problems, but here you can see all the three terms have different bases. So the first step you have to do is convert them into a common base. Now this 9 can be written as 3 to the power 2, which is nothing but 3 into 3, which is 9. So this has been written as 3 to the power 2 to the power whole 2 into 18 can be expressed as, this is simplified and expanded form of 18. That is 9 into 2. 9 into 2 gives you 18. So nothing is changed here. Only the way of writing is different to solve and make it simpler. To the power whole it is 4 and 3 to the power 16 is same. In the next step we see here is 2 into 2 we are going to take the product. Again here 9 can be further simplified as 3 to the power 2, which is nothing but 9. And the rest of the things are the same. When you come to the next step, 2 into 2 we have taken 4 here directly, 3 to the power 4, and here this whole power 4 is applicable to both 3 and 2. So that is why we have taken 3 to the power 2 into 4. This is this 4 which is applied to both the terms into 2 to the power 4. We have just opened these brackets and applied this exponent 4 to both the terms, divided by 3 to the power 16. Now in the next step we can see 3 to the power 4 into, this is multiplied and written as 3 to the power 8 and into 3 to the power 2 to the power 4 is same, divided by 3 to the power 16. This is the simplest form which we can convert this digits. Here we have the simplest form. As you can observe in this 4 different terms, 3 are having common bases. 3 to the power 4, 3 to the power 8 and 3 to the power 16. All these 3 have 3 as common base. So you can solve these 3. Now the only thing you have to observe is this is multiplication and this 3 by 16 is getting divided here. So that is why we have taken 3 to the power 4 plus 8, because this is multiplication, so it becomes m plus n here. So 4 plus 8, but this is m by n, that means you are going to deduct this exponent 16. That is why we have taken minus 16. Do not get confused why it is getting subtracted here, because this is the division function. So that is why you have to deduct. And 2 to the power 4 taken as it is. Now when you solve this 4 plus 8 minus 16, you get 3 to the power minus 4 into 2 to the power 4. This 3 to the power minus 4 can also be written as 1 by 3 to the power 4. We are taking this minus 4 to the denominator. It gets converted to plus 4 as 1 by 3 to the power plus 4 into 2 to the power 4. Now this can also be written as 2 to the power 4 divided by 3 to the power 4, because 3 here is in the denominator. Now 4 and 4 are common bases, so you can further write it as 2 to the power 4 is nothing but 16, 3 to the power 4 is 81. So 16 by 81 is your final answer. Here the only thing is you have to simplify each term and move ahead, and only when you reach the final, this kind of simplest form, you can apply the other rules. So try to convert as much as possible to the simplest form before applying any kind of rules. Now let us look at another problem which seems very complicated when you see it initially. These numbers are so confusing. That is when indices come into handy to solve such complicated problems. Even when you are trying to solve this in your calculators, you might suffer because this has 0.25, 0.13, 0.075 in the powers. So that is when these laws for indices are very useful. Now let us look at this. 243 to the power of 0.13 into 243 to the power of 0.07. You can see these two have the common basis, but these are not simplified form, so we are simplifying it. 243 can be written as 3 to the power 5. In both the places we are writing 3 to the power 5 with the same exponents as it is. And this 7 to the power 0.25, the only thing here changes is 49 and 343. These are not the simplest forms of writing any number. So 49, as you have already 7 here, so you are going to write this and this term also with the base 7. So 7, that means 49 can be written as 7 to the power 2. And 343 can be written as 7 to the power 3 with as it is exponents. Nothing changes here. In the following steps, as you can see, this a to the power m whole power n will be taken as the product of the two exponents m into n. So we are just multiplying this exponent with the outer exponent 5 into 0.13, and in this you are going to multiply in all the things. You are just going to multiply the two exponents wherever you have the brackets. And coming to the next step, you have found the products of all these expressions which you had to multiply. So this can be the simple form. So as you can see, these two have the common basis and the denominators have the common basis. The law of multiplication can be applied at this step. When you reach this step, you can apply the law of multiplication. That is, a to the power m into a to the power n is nothing but a to the power m plus n. So you are adding the two exponents here. As well as in the denominator, you have the three terms, but you have common basis and multiplication sign. So that means you can apply the law of multiplication to add the exponents. So you are adding all the three exponents at once. When you add this and this, you land up to this number, that is 3 to the power 1 divided by 7 to the power 1. 3 to the power 1, 7 to the power 1 is nothing but 3 by 7. Anything raised to the power 1 is nothing but the number itself. So 3 by 7. This is your final answer. When you look at the question, it looks so complicated, but the answer is so simple and the steps are all based on the laws of indices. So here in this video of indices, I think we have made clear whatever the laws that have to be applied in the specific problems. So you can see that we have covered many problems here and all the problems are different from one another. We have not taken the similar problems, so that we have tried that different concepts are covered. What I have gone through is that all the concepts important for your indices problem solving has been covered here. And in this problem, the only thing you have to remember is to apply relevant laws. I have tried my best to give you different problems, the variety, so that you can practice different problems and understand all the different laws and how these multiple laws can be applied to solve all the complicated problems. These simple problems, if you practice well, then you can solve the further problems which are more complicated, and any type of problems you get in your exams. If you are thorough with these laws, you can solve it and get the right answer. Hope you have understood the concept of indices well. One point to be noted is, whenever you are solving problems on indices in your examination, do not forget to mention the laws which you are applying while solving the problem. This makes the problem solving more clear and helps you to get good marks. Thank you for watching. One important announcement: do not forget to watch my next video on logarithms, which will be the part 2 of this video. Thank you.